December 2019. A case of some novel pneumonia-like virus surfaced in Wuhan. By January, 60 people got affected. A month later, however, the world was in a pandemic. As this film got produced, millions of patients around the world, without a second thought, consumed drugs prescribed to them. Drugs suddenly became a dose of our daily news as well, as scientists around the world rushed to find treatments for COVID-19. Remdesivir, dexamethasone, tocilizumab, words that were once nothing but pharmaceutical jargon slipped into the everyday lexicon, becoming topics for dinner-time conversations. But there are other places that drugs ended up too. Places that have, over the course of decades, been transforming into ecological hell. On the 26th of April, 2 years ago, a study was published. In it was a warning of a dangerous future. Yet, of course, the media was quick to ignore it. Because, obviously, the media wouldn't really care if a couple of European male fish became intersexual, would they? The report came from the country which had the highest incidence of HIV in 2019. It pointed at how South Africa had doctors prescribing several tons of drugs every year to combat the disease. Drugs which, after going through the bodies of millions, eventually deposited themselves in the country's waterways, where they forcefully made their unwanted presence known by spawning a chain of negative environmental impacts. Lives were heartened, the environment wasn't. The publication anticipated a dramatic increase in the amount of active pharmaceutical ingredients being released to the environment, with environmental impact being worsened dramatically as the pandemic made it necessary for more and more drugs to be manufactured. Stumbling across this unique perspective on COVID-19's impacts led me to seek my friends' opinions. Their thoughts largely resonated with mine. Saving lives is much more important right now. Environmental considerations can be saved for later. And it was then that I grasped the true extent to which pharmaceutical pollution was a largely unheard of problem. A multitude of drugs used every day pass through people's bodies unaltered by the digestive system and flood the sewers, where sewage treatment plants fail to filter all of them. At the point of manufacturing, these chemicals escape from separation apparatuses and reactors and trespass into the waterways. Rivers and lakes get their share from the sunscreens and body lotions that get washed off the bodies of swimmers. As many as 600 of these pharmaceutical chemicals, from medications and drugs to shampoos and soaps, are present in the environment worldwide. The concentrations at which they foul our soils and waterways are on a slow yet incessant rise, a rise that is already beginning to unveil its effects. Once present in water, these pollutants start unleashing hell on all the organisms that consume them, and some effects are particularly harsh. Pollution of the anti-inflammatory diclofenac in Asian environments, for example, has eradicated more than 90% of all vultures in Asia. Contamination from a contraceptive pill in Europe's rivers has rendered majority of all male fish intersexual. With the grim cloud of COVID-19 already looming, a cloudburst of drug manufacturing and usage is occurring, and the foretelling of the South African study is worrying environmentalists about the future of planet Earth. Nevertheless, this pharmaceutical frenzy is needed to save lives and end this pandemonium, all the while adding to the pre-existing environmental pandemonium. So, what on earth needs to be done? Long-term solutions comprise, firstly, researching ways to manufacture biodegradable drugs, that is, substances that disintegrate in the environment, or secondly, tweaking sewage treatment plants to become more advanced. With Swedish attempts at the second strategy having proven it financially nonsensical, the first strategy seems to be attracting the limelight. And the research of American chemist John Warner, who seems to have found a method to make biodegradable drugs truly effectively, seems to have concrete solutions. It may be the first step in avoiding grim die-offs and dramatic sexual anomalies of entire populations of animals. Professor Warner's method includes substances called non-covalent derivatives, or NCDs. In a nutshell, these are pairs of chemical work partners that collaborate on a project until it is finished, after which they part ways. These two colleagues are molecules that carry out their jobs until being released into the environment, where they bid adieu and disintegrate. Most pharmaceutical chemicals are currently formulated as single colleagues, and Warner is working to convert many of them to NCDs by giving them a work partner, an unstable sort that would allow biodegradation upon leaving the body. While it is true that the broken down products could sometimes be toxic, his research has demonstrated, though, that the technique is majorly fruitful. COVID-19 is social pandemonium. Yet resolving it does not have to fuel environmental pandemonium. While the pandemic's still here, shifting all the focus on implementing NCDs may only increase the turnaround time of newer drugs, which nobody wants, but taking small steps in the process would undeniably go a long way. And in a decade, the environment might not need to be a price that we pay.